In this video, we are going to create our concatenation list from 2 columns. And then we're going to learn how to switch subroutines over to functions. I brought in a few dates over from our order date column in the mock data. We're going to loop through these columns and match the customer number with the order date, separated by a comma. Each customer number and order date pair will be surrounded by parentheses, and each of these pairs will be separated by a comma. Borrowing again from our special concat commas 2, and change the name to multi-columns. We will need 2 new variables for each of the concat values. We will need a concat value 1 and a concat value 2 for the strings. We will continue to use our active column to get the first column. In the second column, we will go into the for each loop, and the concat val 2 will be equal to the value to the right of the active column. We do this by using the concat value offset by 1 column. Now we want to trim both of our concat values. We will only check for irregular data in the first column, but you can expand it to check both columns if that suits your needs. In our concat string, we will add parentheses, and we will add the second concat value with a comma between the values. In the previous video, I mentioned that if we assign concat value to the trimmed version of concat value, that it would lose some of its functionality. This is where we can see that. If we try to calculate the offset value for concat value 2, it would only be a string and not a variant, so it would lose its ability to calculate offset range values. And when we run this, we can see that our concatenation string has our customer number and the date separated by a comma, surrounded by parentheses, and the pairs are separated by commas. This works fine as long as we always want the data that is in the first and second columns respectively. But it is better to make our macros dynamic when possible. One way to do this is to make our macro a function instead of a subroutine. As a review, the user-defined functions require at least 1 parameter, just like Microsoft functions, and they will return a single value. For our function, we will be using 2 parameters, the numerical values of the columns that tells us the location of the data we are going to concatenate, and we will be returning the single value of the concatenated string. We will copy over our special concat multi-column subroutine, and then we will replace sub with function, and this will automatically be changed at the end of the macro. We will remove the message box for the incorrect column choice because our user-defined function will take the column numbers as the parameters of the first and second column. We will put the parameters inside the parentheses of the function name. We will need the name of the variable and the data type. So we will use concat call 1 as long and concat call 2 as long for the column numbers. We will also need to put the data type of the value that is being returned at the end of the function outside of the parentheses, which is a string. If we do not define the data type of the return value, Microsoft will make it a variant which can yield unwanted results. We will need to adjust the column variables for the last row value and the concat range values. We will need a new long variable to determine the location of the second column. Previously, we offset the value of the second column by 1, which is 1 column to the right of the first column. If we make the second call value to be equal to the calculation of the number of the second column minus the number of the first column, the result will give us a location of the second column in respect to the first column. If the result is negative, then the offset value will be the number of columns to the left of the first column instead of the right. We will see that that works nicely in our original set of data. Since our function won't be run in a subroutine, we won't need to tell it where to put our string in the Excel sheet. We will make the function name, which is the variable expected to hold the final value, equal to the clean concatenated string value. We will no longer need our lcall variable. Yes, we will need to rename the function because subroutines and functions can't have the same name in the same module, even though they're different types of macros. And we will also comment out our last column code. Back in the Excel sheet, we will find our function by going to FX and selecting the user-defined category. And we see our function in the list. Well, it's the only function in the list. When we click OK, we are asked to provide the column number parameters, which are 1 and 2. And we get a sneak preview of our data, which is a good indicator that it's working correctly. And we can see that it matches the data output from our subroutine. Let's try this in our original data. We're going to get the shipping data first, which is column 6, and then the customer number, which is column 1, to show that our negative offset value is counting correctly and is counting to the left. And this is the data we are expecting. The next thing we want to consider is that we are asking the user to calculate the number of the column. In a small set of data, this is a simple task, but this isn't very user-friendly, especially if your columns get into the doubled letters. It would be easier if the user could simply select the desired column, and the macro calculates the column number from the cell range. Back in the VBA, we will take out our column number variables, and we will change our parameters to a range variable. Let's go ahead and delete the extra code we don't need. And we will set each column number variable to get the number from the range that's being passed in by the user. And yes, we need to change the data types from long to a range. Back in the Excel sheet, we will again go to our user-defined function, and this time we will select a cell for each of the desired columns. And our preview data shows that it's looking good. Click OK, and we can see the data looks good. The last thing we're going to do in this video is to review a topic from the first project. So far we have set everything up as a for each loop. We're going to translate our for each loop to a for loop. As mentioned in the video on converting to for each loops, all of these macros are simple and both types of loops will run quickly. First, we need to do a little house cleaning. We won't need the second call variable or any of the concat values or the concat range. We will need a single concat value as a long to loop through our for loop. We won't need to set the range, and we won't need to calculate the second call. We will comment out our for each loop. We will have our for loop go through the second row to the last row, and we will check if the cell value is blank or -1. And we will set up our concat string to bring in the values of each cell by its row and column coordinates and trim them as we bring them in. And to check this, we again will go to the user-defined function, put in our columns, and the data matches the first row. We'll clean this up a little bit so that we can see the difference between the for each and the for loop. The for loop looks a lot simpler than the for each loop. Which loop should we use? Besides worrying about speed, these small macros may become steps in larger projects. Depending on the needs of those projects, one method may be preferred over the other. And depending on your preference or needs, any of these subroutines can be switched over to a function, since all of these take in at least one parameter, the column number, and return one value, the concatenated string. If you like the extra practice of switching between the types of loops and switching between subroutines and functions, you can do this on your own using any of the macros, and I will put my solutions on GitHub.